Hello everyone. What is coordinate geometry? The use of algebra to study geometric properties, that is operates on symbol, is defined as coordinate geometry. So today let us discuss something more related to this in our lesson coordinate geometry. A system of geometry where the position of points on the plane is described using an ordered pair of numbers is coordinate geometry. The method of describing the location of points in this way was proposed by the French mathematician René Descartes. He proposed further that curves and lines could be described by equations using this technique, thus being the first to link algebra and geometry. In honor of this work, the coordinates of a point are referred to as its Cartesian coordinates, and the coordinate plane as the Cartesian coordinate plane. Some basic points. To locate the position of a point on a plane, we require a pair of coordinate axes. The distance of a point from the y-axis is called its x-coordinate or abscissa. The distance of a point from the x-axis is called its y-coordinate or ordinate. The coordinates of a point on the x-axis are of the form x0 and of a point on the y-axis are of the form 0y. This is how a coordinate plane looks like. Here is coordinates consisting of abscissa and ordinate. These are the four quadrants of coordinate planes. The distance formula is showcased as like this. Distance formula. Let us now find the distance between any two points px1 and y1 and qx1 and y2. Draw PR and QS perpendicular to x-axis, perpendicular, and from the point P on, QS is drawn to meet at the point T. So, OR is equal to x1, OS is equal to x2, PR is equal to PS is equal to y1, QS is equal to y2. Then PT is equal to x2 minus x1, QT is equal to y2 minus y1. Now applying the Pythagoras theorem in triangle PTQ, we get PQ square is equal to PT square plus QT square. Therefore, PQ is equal to the whole root square x2 minus x1 square plus y2 minus y1 square, which is called as the distance formula. Example 1. Find the distance between P in the bracket 1, minus 3 and Q in the bracket 5, 7. Distance PQ D is equal to the whole square root in the bracket x2 minus x1 square plus y2 minus y2 square. D is equal to the whole square root in the bracket 5 minus 1 square plus 7 minus 3 the whole square. D is equal to root 116. D is equal to 2 root square 29. The exact distance between A in the bracket 1, minus 3 and B in the bracket 5, 7 is AP is equal to 2 root square 29. Distance from origin. Distance of P in the bracket xy from the origin is root square x minus 0 square plus y minus 0 square is equal to square root of x square plus y square. Applications of distance formula. To check which type of triangle is formed by given 3 coordinates, and to check which type of quadrilateral is formed by given 4 coordinates. Parallelogram. Prove opposite sides are equal or diagonals bisect each other. Rhombus. Prove all 4 sides are equal. Rectangle. Prove opposite sides are equal and diagonals are equal. Square. Prove all 4 sides are equal and diagonals are equal. Collinearity of 3 points. Use distance formula. Collinearity of 3 points using distance formula show that A plus B is equal to C. Section formula. Consider any 2 points A, x1, y2 and B, x1, y2 and assume that Pxy divides AB internally in the ratio m1:m2. That is, PA upon PB is equal to m1/m2. Draw AR, PS and BT perpendicular to x-axis. Draw AQ and PC parallel to the x-axis. Then by the AA similarity criterion, section formula for x coordinate taking m1/m2 is equal to x minus x1 upon x2 minus x, or m1 in the bracket x2 minus x is equal to m2 in the bracket x minus x1, or m1x2 minus m1x is equal to m2x minus m2x1. m1x2 plus m2x1 is equal to x in the bracket m2 plus m1. So x is equal to m1x2 plus m2x1 the whole divided by m2 plus m1. Section formula. Triangle PAQ congruent to triangle BPC. PA upon BP is equal to AQ upon PC is equal to PQ upon BC is equation 1. Now AQ is equal to RS is equal to OS minus OR is equal to X minus X1. PC is equal to ST is equal to OT minus OS is equal to X2 minus X. PQ is equal to PS minus QS is equal to PS minus AR is equal to Y minus Y1. BC is equal to BT minus CT is equal to BT minus PS is equal to Y2 minus Y. Substituting these values in 1, we get m1 upon m2 is equal to, in the bracket, x minus x1 upon, in the bracket, x2 minus x, which is equal to y minus y1 in the brackets, again in the brackets, y2 minus y. Section formula for y coordinate taking m1 upon m2 is equal to y minus y1 in the brackets divided by y2 minus y again in the brackets, or m1 in the bracket y2 minus y closing the bracket is equal to m2 in the bracket y minus y1 close the bracket, or m1 y2 minus m1 y is equal to m2y minus m2y1, or m1 y2 plus m2 y1 is equal to y in the bracket m2 plus m1. So y is equal to m1 y2 plus m2 y1 divided by m2 plus m1. Midpoint. Midpoint of A x1 y1 and B x2 y2. M is to n is equal to 1:1. Therefore P is equal to, in the bracket, x1 plus x2 upon 2, comma y1 plus y2 upon 2, close the bracket. Find the midpoint of P in the bracket 1 minus 3 and Q in the bracket 5, 7. Midpoint of PQ is equal to formula. Then we are substituting the values in the formula. 5 plus 1 upon 2, comma 7 plus of minus 3 upon 2, which gives us 6 upon 2, comma 4 upon 2 is equal to 3, comma 2. Area of a triangle. Let ABC be any triangle whose vertices are A, x1, y1, B, x2, y2, and C, x3, y3. Draw AP, BQ, and C are perpendiculars from A, B, and C respectively to the x-axis. Clearly, ABQP, APRC, and BQRC are all trapezium. Now from the figure, QP is equal to x2 minus x1, PR is equal to x3 minus x1, and QR is equal to x3 minus x2. Area of a triangle. This is the figure showing the following graph. Area of a triangle ABC is equal to area of trapezium ABML plus area of trapezium ALNC minus area of trapezium BMNC. Area of a triangle ABC is equal to area of trapezium ABQP plus area of trapezium BQRC minus area of trapezium APRC. We also know that area of trapezium is equal to half sum of parallel sides multiplied by distance between them. Therefore, area of triangle ABC is equal to half BQ plus AP multiplied by QP plus half BQ plus CR multiplied by QR minus half AP plus CR multiplied by PR is equal to half y2 plus y1 multiplied by x2 minus x1 plus half y2 plus y3 multiplied by x3 minus x2 minus half y1 plus y3 multiplied by x3 minus x1. y2 x2, y1 x1 and y3 x3 cancel out each other, remaining with half in the bracket minus y2 x1 plus y1 x2 plus y2 x3 minus y3 x2 close the bracket minus y1 x3 minus y3 x1. So now it is equal to half in the bracket x1 again in the bracket y3 minus y2 close the bracket plus x2 open the bracket y1 minus y3 plus x3 in the bracket y2 minus y1 close the bracket. Now let us find the distance between 2 points P x1 y1 and Q x2 y2. Example, find the distance between A 1, minus 3 and B 5, 7. D is equal to the whole bracket square x2 minus x1 the whole square plus y2 minus y2 the whole square. Show substitution into formula clearly. Substitute the values in the formula, then we get D is equal to the whole root square 5 minus 1 the whole square plus 7 minus of minus 3 the whole square. D is equal to root 116. D is equal to root 4 multiplied by root 29, which is equal to D is equal to 2 square root 29. The exact distance between A 1, minus 3 and B 5, 7 is AB is equal to 2 the square root 29. Example 2. Find the distance between P minus 3 and 5 and Q 5 minus 5. Substitute the values in the distance formula. So D is equal to the whole root square in the bracket 5 minus of minus 3 the whole square plus minus 5 the whole square. D is equal to root square 164. D is equal to root 4 multiplied by root 41, which is equal to D is equal to 2 root square 41. The exact distance between P minus 3, 5 and B 5 minus 5 is PQ is equal to 2 square root 41. Midpoint of 2 points P x1 y1 and Q x2 y2. Example 1. Find the midpoint of A 1, minus 3 and B 5, 7. Formula: average point divided by coordinates. Midpoint of PQ is 2 bracket x2 plus x1 upon 2, y2 plus y1 upon 2, close the bracket. Substitute the values in the formula. So we have in the bracket 5 plus 1 upon 2, 7 plus of minus 3 upon 2. Then x upon 2, 4 upon 2, which is equal to 3, 2. The midpoint of A 1, minus 3 and B 5, 7 is 3, 2. Second one, find the midpoint of P minus 3, 5 and Q 5, minus 5. Substitute the values in the formula, which is equal to 5 plus of minus 3 upon 2, minus 5 plus 5 upon 2, close the bracket, which is equal to 2 upon 2, 0 upon 2. So it is equal to 1, 0. The midpoint of P minus 3, 5 and Q 5, minus 5 is 1, 0. So this was all about our lesson coordinate geometry. Lots of coordinate geometry is used to find the shortest path and the distance between them. It can be used to find the position of any object from its original position to the present position. So learning about it is very important. Thank you, students.